Imagine a comet drifting silently across the vast void of interstellar space. A lone traveler, ejected from its home star billions of years ago, carrying secrets older than Earth itself. It drifts in darkness, cold and isolated, a relic of a time when our galaxy was young. But this is no ordinary comet. This is 3I Atlas, a cosmic enigma that challenges everything we thought we knew about icy bodies in the universe. It is a visitor from another star system, an interstellar wanderer, and its story is unlike any comet we have ever observed. In July 2024, NASA's Swift Observatory trained its ultraviolet eye on this mysterious object. What it detected would astonish even seasoned astronomers. 40 kilograms of water were vanishing from 3I Atlas every second, far from the Sun, in a region where even our solar system's most active comets usually remain dormant. Steam erupted from the comet like a cosmic fire hose, a display of activity never before seen from an interstellar visitor. And yet, this torrent of water was only the beginning. Swift's ultraviolet instruments detected a subtle yet unmistakable signal: hydroxyl radicals flaring in the vacuum of space. These radicals are the chemical fingerprint of water molecules breaking apart under sunlight. Over a week of stacked exposures, scientists carefully measured the output, confirming an astonishing rate of water loss, nearly 40 kilograms per second. To put that into perspective, imagine a fire hydrant in a city, blasting water into the streets. Now multiply that by the scale of a comet drifting almost 3 times farther from the Sun than Earth. This was not a trickle. It was a torrent. Most comets at 2.9 astronomical units are silent, their water ice locked away beneath layers of frost. Yet Atlas was spilling water into space with abandon. Scientists calculated that at least 8% of its surface must be actively sublimating to match the observed outgassing. For a nucleus estimated at 5 to 6 kilometers across, that translates to more than 7 kilometers of exposed, sunlit ice, a surface area far larger than what is typical for comets at this distance. But Swift's observations revealed something even more intriguing. The ultraviolet emission was not concentrated at the nucleus. Instead, it spread across an extended cloud, a hint that the comet's water was not only escaping from the core, but also from countless icy fragments drifting through the coma. Sunlight striking these grains could sublimate water, acting as miniature steam vents scattered across tens of thousands of kilometers. Near-infrared observations from Gemini and IRF confirmed the presence of water ice throughout the coma. The Swift team's haze models, which translate hydroxyl emission into water production, accounted for this extended source, but the numbers still pushed the limits of standard comet physics. Every measurement was double-checked, calibrations verified, background emissions subtracted, sensitivity limits debated. Yet the signal persisted. The conclusion was inescapable. 3I Atlas was venting water at a rate and in a manner never before observed in any interstellar comet. Just days after Swift's observations, the James Webb Space Telescope turned its powerful instruments toward Atlas. Using MIRI and NIRSpec, JWST captured spectra that revealed a chemical signature almost unheard of among comets. The results were astonishing. Carbon dioxide dominated over water by nearly 8 to 1. In most comets, water is the dominant volatile, with carbon dioxide playing a supporting role. Not here. The JWST data also detected carbon monoxide and traces of carbonyl sulfide, a sulfur-bearing molecule rarely found in such abundance. Spatially, the comet's volatiles told 2 very different stories. Water appeared patchy, erupting from isolated vents or icy grains, while carbon dioxide formed a smooth, uniform halo across the coma. This contrast suggested that the 2 compounds were being released by fundamentally different processes, or perhaps from separate regions within the nucleus and its surrounding debris. The chemical makeup hints at a complex history. High carbon dioxide abundance could indicate formation in a carbon-rich, frigid zone beyond the CO2 ice line of its home system. Or it might reflect the cumulative effects of billions of years of radiation in interstellar space, processing the comet's surface while leaving deeper water ice trapped. This chemical fingerprint, unlike anything seen in local comets, suggests that Atlas carries a record of conditions far beyond the solar system. a relic from a corner of the galaxy most of us will never see. The comet's unusual chemistry is one piece of the puzzle. Its orbit adds another layer of intrigue. Avi Loeb, a Harvard astrophysicist known for entertaining bold hypotheses, noticed something peculiar. Atlas' path through the solar system threaded 3 planetary approach windows in rapid succession. Its perihelion coincided with Earth's solar conjunction, creating a weeks-long blackout during which the comet was invisible from almost every telescope on our planet. In orbital mechanics, such a window is ideal for a hypothetical spacecraft to execute a solar slingshot maneuver. Loeb speculated, if Atlas were artificial, this would be the moment it could act. He pointed out additional anomalies, early measurements of brightness, unusual dust configurations, and ambiguous size estimates. Individually, each observation could be explained, but together they form a cluster of anomalies that is difficult to ignore. Loeb's hypothesis is falsifiable, not purely speculative. He predicted that if an artificial component existed, it would become most evident between November 21st and December 5th, 2024, when the comet re-emerges from the sun's glare. The Galileo project, a network of telescopes and sensors under Loeb's direction, prepared to monitor every motion, outbursts, accelerations, and any fragments diverging from the main body. Mainstream astronomers remain cautious. Extraordinary claims require extraordinary evidence. So far, Atlas fits within the boundaries of natural comet physics, but the anomalies are compelling enough to warrant close observation. On October 29, 2024, Atlas reached perihelion, skimming just 1.36 astronomical units from the Sun. From Earth, the comet vanished behind the solar glare, hidden from even the most powerful telescopes. This blackout created a tense period for astronomers. Without direct observation, predictions became guesswork. Models could simulate how sunlight might drive activity, or estimate how the nucleus would respond to heating. But models are not reality. Would Atlas flare into superactivity, shed fragments, or remain silent? Observatories around the world tried every workaround. Some observed using solar coronagraphs. Others attempted oblique spacecraft perspectives. Scientists monitored solar wind spikes for indirect evidence. Even classified satellites were rumored to have caught glimpses. Yet nothing definitive emerged. Atlas remained hidden, its fate suspended behind the sun's glare. Meanwhile, on Earth, the story unfolded across the internet. Social media lit up with speculation. Amateur astronomers shared blurry images, light curves, and elaborate timelines. Hashtags like Chang Alien Atlas and Char Cosmic Sprinkler trended as the public debated natural comet, extraordinary comet, or something far stranger. While Earth waited in the shadows, the European Space Agency, S-Trace gas orbiter, turned its instruments toward Atlas as it swept within 29 million kilometers of Mars. Between October 7, 2024, the spacecraft captured a series of images showing a coma stretching between 4,000 and 8,000 kilometers. The gas and dust glowed faintly in scattered sunlight, forming a vast, diffuse envelope around the bright nucleus. Analysis confirmed a single compact core. There were no signs of fragmentation or secondary nuclei. Color data revealed a subtle blue gradient in the outer coma, consistent with sunlight scattering off small icy grains. These fragments likely contributed to Atlas's extraordinary water output, confirming ground-based hints. The campaign was technically challenging. Exposure times, pointing accuracy, and data transmission across interplanetary distances had to be balanced perfectly. The reward: independent confirmation that Atlas remained intact on the eve of perihelion. A rare moment of certainty in an otherwise mysterious journey. Comets are fragile worlds precariously balanced between ice, dust, and sunlight. When exposed to intense solar heating, internal pressure builds as subsurface ice sublimates. Thermal gradients between sunlit and shadowed regions can crack or blow out weak spots. Jets of gas act like thrusters, spinning the nucleus faster and amplifying stress. History is full of dramatic examples. Shoemaker-Levy 9 shattered under Jupiter's tidal forces in 1992, colliding with the giant planet. Comet 73P Schwarzmann-Wachmann 3 fragmented into multiple pieces near perihelion. C209Y4 Atlas, another highly active visitor, crumbled unexpectedly near the Sun. Yet some comets survive. If outgassing remains balanced and symmetric, it vents pressure without destroying the nucleus. Astronomers watch carefully for signs of instability, sudden brightness changes, splitting nuclei, or spreading debris. For Atlas, these signals could be the difference between survival and spectacular cosmic destruction. Beyond its behavior, Atlas is extraordinary for its origin. Galactic modelers traced its path through the Milky Way's thick disk, a region populated by stars nearly as old as the galaxy itself. Its inbound velocity, clocked between 60 and 67 kilometers per second, marks it as unmistakably interstellar. Inside its 5 to 6 kilometer nucleus, layers of ancient ice have likely survived since the dawn of planetary formation. A rotation period of 16 hours cycles the surface between sunlight and shadow, preserving pockets of chemistry predating our solar system. Each molecule released into the coma carries a message from another corner of the galaxy, a record of worlds formed under alien suns. In essence, Atlas is a time capsule, a relic traveling across the void, offering humanity a rare glimpse into the conditions that gave rise to planetary systems billions of years ago. While speculation runs wild, seasoned astronomers maintain a grounded perspective. Tom Statler, Chris Lintott, and Jason Wright emphasize that all current observations remain within the bounds of natural cometary behavior. Thermal emission aligns with expectations for sunlit ice and dust. The orbital path matches predictions, showing only subtle nudges from outgassing. No anomalous acceleration, unexplained heat, or artificial signals have been detected. The exotic chemistry can be explained by formation in a cold, carbon-rich environment, exactly as planetary system diversity models predict. Until the comet reappears in November 2024, every anomaly is a challenge for comet science, not a breach of natural law. The coming weeks are critical. ESA's JUICE spacecraft will monitor Atlas between November 2 and 25, 2024, from a vantage point far from Earth's interference. The mission includes high-resolution imaging to detect fragments or jets and spectroscopy to track changes in water and carbon dioxide output. On the ground, professional and amateur astronomers will coordinate to reacquire the comet as it clears the horizon. The Galileo project's sensors stand ready to flag any non-natural activity. Every frame, every spectrum, becomes a data point in a decision tree. Will the comet brighten, expand its tail, or fade into silence? Will fragments appear, or will something truly unexpected occur? Patience is required. JUICE's raw data will not arrive until February 2026. Until then, the world waits. 3I Atlas remains a cosmic riddle. Its extraordinary water loss, unusual chemistry, and interstellar origin highlight nature's capacity to surprise and astound. The November observational window may finally reveal whether this is a comet pushed to extremes by natural forces, a fragmenting celestial body, or something even stranger. For now, humanity watches. In every speck of ice, every molecule of gas, 3I Atlas carries a message from the stars, a story billions of years in the making. And in this silent journey across the solar system, it reminds us that the universe still holds mysteries far beyond our understanding. In the endless darkness, a single comet drifts ancient and silent, and for a brief moment, it brings the galaxy to our doorstep, whispering secrets of worlds we may never see, and of a universe far more complex than we ever imagined.